and I hope you are doing well. Today I did a model of the composite beam under the blast load, which is made with two layers of the wood, concrete and the CFRP. And here, if we remove the concrete, we can see the steel reinforcement inside this composite column, and we use two methods to define the material here. First, for the concrete, we use concrete damage plasticity without damage as the input file, and in the second we use that. So let me click on this. This is the model that we use, concrete damage plasticity. Let me check the damage parameter for the CFRP. This is the compression for the fiber, tension for the fiber. You can see it is fully damaged, see, under the blast load. If I click on animate, you can see here. You can see that. Let me now check the concrete. Replace the concrete if it let us. Okay, and let me request the compression damage. You can see the tension damage. It is fully damaged. A stiffness degradation or anything else. Now let me remove the CFRP, the concrete. You can see the steel reinforcement, and now here the wood with two layers in compression and tension. In the second model here, you can see the concrete failed completely. Check here the damage for the CFRP with 8 layers here. And now let me check the compression damage just for the concrete. Here, this is the concrete. If I click on animate, see, it is failed completely. Nothing happened here. And let me now check the stress. Remove the CFRP, remove the concrete, and you can see the steel reinforcement and the wood here. This is the stress, plastic strain or deformation. Okay, this is two model with two methods for the air blast load over the composite column, and also we have reaction force for both. You can see there is a huge difference between both models, and that's the difference we use. In the blue we use a strain damage capability for the concrete, but in the red we didn't use that. So that's the difference between two models. We explain both as a step-by-step video tutorials and explain the material, step interaction, load, anything. So if you need to model the composite column, especially the composite column with wood, concrete and FRP like CFRP, under the compression, tension or blast load, you can use this tutorial. So if you wanted, come to our website. Our website here, www.abaqusfm.com. Find the English tutorial here. Click on title. Then you will have the part definition. Here these are the figures of the part, material method, step interaction, load, and then the result as figure. You can see them here. The file contains CAE, INP, and English video file step by step for both two analyses, and the cost for that is €30. You can use a PayPal account, a Visa or MasterCard for the payment. Before that, send me an email to tell you about the purchasing process and also the more explanation about the simulation. So Here we have also a full package, contains around 400 cases that contain all things about the Abaqus in simulation and modeling, and you can learn everything from this package, and you will be a master after watching all the tutorial and running them. So you can see the main titles of the package here, and it includes anything in Abaqus. You know, with this package you will be a professional user in Abaqus, and the cost for that is so exceptional, you know, for the student, engineer, or teachers. Just contact me to this email to get this exceptional package also. So thank you for your attention.